Hello everyone. So we are now at the final part of our hypothesis testing. All right. So earlier we have looked at two tilt tests. We actually started with two tilt tests, and then after that we look at one tilt test. Yeah. So two tilt tests is usually related to equal or not equal to. For one tilt test, less than, more than. All right, so in this part of the video, we're actually going to look at difference between two means. All right, so let's have a look at how this actually look like. All right, so what this basically means is that we actually have two samples. All right, and then we want to compare these two samples to decide which one is actually better than the other. All right, so usually this is comparison. And how do we go about it if we actually have two samples and then we have two means, right? So just a slight difference when it comes to the formula, right? Earlier, remember, you actually have your exact formula and you calculate what it is and all that. So difference for between two mean sample, all right, will give you formula that looks like this. All right, remember your z is usually x minus mu over standard deviation, right? Your sigma. So in this case, if I have two samples, I will have x1 minus x2. All right, minus mu1 minus mu2 over my standard deviation. And how do we go about the standard deviation? The standard deviation goes by this. Remember, usually my standard deviation for sample is actually sigma over square root of n, right? So in this case, you will see that it's just the same. Only that now I actually combine the first and the second sample. Alright, so the subscript here is just to really indicate that this is from the first sample and this is from the second sample. Alright, so this for population 1, this is for population 2. Alright, well, now that we have looked at the formula, let's try to look at an example of how it is. Okay, so again, let's look at example here. I'm going to leave this formula here for you to see. Let's see, we want to look at response time. All right, response time for two hard drives. Okay, they're measured in time, of course, and then the values are given as, let's take this as sample 1 and then this is a sample 2. All right, so sample 1, they actually tested 35. Sample 2, they actually have 38 of them. And then what do you have for the mean? 16. And x2 bar is actually 13. So the standard deviation, the s over here, actually this is sigma. Okay, let's just play with the consistency. So sigma 2 is actually 4. Alright, so now they are asking, is there a significant difference between the response time? Alright, so let's say the question also gives you a significance level of 0.05. They're asking you, is there a difference, a significant difference between the two response time? All right, between the two. So what this tells us is that we are going to compare based on the results of, or based on the data of these two samples. All right, so if we look at whatever that we have over here, this is just the formula, right? Again, we go back to the first ever rule of our how-to. Remember the step for proceeding and starting with the hypothesis testing. Of course, we always start with setting my H0 and my H1. All right, so in this case, you want to see whether there is difference or not. So how do we go about this? So in this way, we are going to say mu1 minus mu2 is equals to 0. All right, no difference, which means the mean between the two will not have difference. And of course, my h1 will then be h mu1 minus mu2, not equal to 0. All right, so that was the first step. And after you have known the significance level, yeah, significance level is 0.05. Again, you want to see whether it's 2 tilt tests or 1 tilt test. And again, remember, since it's equal or not equal to, then it becomes a 2 tilt test. 2 tilt test, it means that you will have to get a 0.025 for your alpha. Yeah, because it applies to both sides of this part here. And then after that, we want to solve it. And how we solve it is exactly by using the formula earlier. If I just write it down again, this is x1 minus x2, and then minus mu1 minus mu2, alright, divided by my standard deviation, which is basically just my sigma 1 square over n1 plus sigma 2 square over n2. Alright, I actually have the information ready all in the table already. So basically what you do is just putting it inside. Yeah, so your mu sample mean for sample 1, it gives us 16, isn't it? So 16 minus 13, I'm just going to write down everything that I have here. And of course, we are testing this that there's no significance difference, isn't it? So your mu1 and mu2 is actually just 0 here. So you actually get it from here. Usually you can extract this information, especially when it comes to comparing between two sample means, right? And you will basically get this from the data in the question itself. Divided by 5 square over my n is actually 35 plus 4 square over 38. And of course, don't forget the square root. And after calculating this should give you about like 1.066. Well, 16 minus 13 is just basically 3. So divide those two and it gives you about 2.81. Alright. So now, the decision part, isn't it? So see that we actually have this thing here. And again, remember, if you remember earlier, your ZA, which is your Z 0.025, where you find the probability of 0.025 given by the Z value of 1.96, isn't it? So, in other words, this is actually, this part here is 1.96. This part here is just negative 1.96. Alright? So these are my rejection region. So for us to know whether it's rejected or not, we see whether it is in rejection region or not. That applies to my H0, right? So now this of the point that we already found is 2.81. So where does this lie in? Alright, and I'm going to use 2.81. So it's actually somewhere here. I'm going to just put a bigger shade here, and this is 2.81. So what does this tell you? Finally, the decision part. Since your 2.81 is in the rejection region, alright, so again, what do you think? And since it is in rejection region, as always, H0 is therefore rejected. Okay? And if you just, and what does this mean then? If you refer back to your H0, H0 actually claims it to be or assumes that there is no significant difference between the two samples. And because H0 is rejected, it now tells us that there is actually a significant difference in response time between the two samples. All right. So that's just basically how it goes. Now that you have looked at several examples, whether it's one tail, two tail, or difference between two samples, you can see that the way for us to do it is just exactly the same, just by the few rules that you have. Now you just want to make sure that you do understand whether it's one tail test, two tail test, and then you just want to remember some parts on how we decide whether your null hypothesis is rejected or accepted. So I suggest that you actually do some exercises. You have quite a lot of that I actually share with you. So with that, good luck. All right. And then this pretty much sums up the first part of our course. All right. And in fact, the second part of the course will be slightly different and it's going to be very interesting as well. All right. Good luck.